please. It's really slow because I think it has to... I hope this is right because it's going to be embarrassing if it's not. Oh, yes! Okay, so you can see now I is 10, J is 20. So it was really slow because like the debugger had to do some foo to actually, like every time it got there, it had to stop, check the value, start it up again. I think that's probably why it's slow. Do you? Yeah? Okay. Okay, so
it's so nice when your variables change, they get highlighted in yellow. So
yeah.
You have a bunch of things displayed.
Yeah. Okay. Really quickly, I just want to point out that if you use Intel Debugger, which is free for Linux, if you use Intel Compiler, which is free for Linux, it comes with a free Intel debugger called IDB. I'm going to just compile this real quick. Again, it's -G -O0 /test.f90 and then IDB. So I found that in general, like a lot of like the problems with DDD go away in IDB. So it's nice in that sense. It looks a lot the same. It's fancy. It's Java. Again, you can see. It sometimes asks me that, which I don't know what that means exactly. But down here, you can see there's this same little prompt, but instead of the GDB debugger, it's the prompt for IDB, which has a lot of the same syntax. So I'm not going to say anything else about this, but if you're using a Fortran program, you're using G-Fortran, you're having a lot of trouble debugging it, a good next step is to get Intel Fortran and run it in IDB.
Okay, so I see you were looking at a function or the source code for the file that you compiled, I mean the executable file itself.
Yeah.
What if the problem is in a module?
A module?
Yeah, in a module function.
Okay, well in that case I did just stop in there. You mean if it's in a different file?
Yes, sir.
Okay, we're going to look at that right now. So we're going to use Cooper again. I've got a little Cooper executable that I compiled, again with -G.
Cooper is C++, right?
Yeah, but it's exactly the same principle. Well, I don't understand. So what is the
module? I mean, what if
you'd have to compile everything?
You see test.f90.
Yeah.
This is a file that was compiled against some module.
Okay.
A.out.
Right.
What if the problem is in the module function?
Oh, then you have to. So like, and let's say that module is in an external library.
Yes, sir.
Then you have to compile that library with -G. And -O0,
but
and then
what if it doesn't have an executable?
Well, it should still have like a library, a .a file that you actually link to.
You get to it from inside your main code.
I can show you an example of an external library here, or I don't think I can.
I got you. I think
okay.
It isn't actually coded .mods.
Yeah, there isn't. It's just the declarations of the function.
Yeah, but you can have a module function, right? Or
right, but there's no code in that. It's generated. It's just text. If there's a bug in some other part of your code, right? It's in some .f90 file somewhere.
Sure.
Right.
Yeah.
And so long as you've compiled it with debugging symbols for the file that has the problem, your debugger will find it. If it's in some external library that doesn't have debugging symbols compiled, then it won't be able to find
You're
it.
so right, but I mean, so you created an F90, which if you compile it, but it's a module.
Right.
It's a module. When you compile it, it becomes mod, okay? And then you'll have an executable in an F90. This is the file that you compile, again, it's the mod.
So the source code for the module
will exist
in some library, not in the .mod. I'll talk to you about it afterwards. Sure. We can take a look. So I just started up Cooper in the debugger. So Cooper needs some command line arguments. So I'm going to have to go to program run where I can enter the command line arguments here. It has too many command line arguments, I should say. That's 3. That's not too many. So I have to make my little grid file. Okay, that's fine. All right, there it goes. All right. Gutter sphere.h5. Did I spell gutterly right? I don't think. Yes. Okay. Sorry that took so long. But I'm going to run this. It's going to run like normal. But oh no, it's gonna run a little bit, and then it's gonna print this thing that says program receives signal SIG FPE, which stands for SIG floating point exception. So immediately I know that I divided by 0 or something like that. If I type where, it's gonna tell me exactly where that error was. So it was main main called Cooper run, called Cooper advance, called Hydro advance, called compute force, yada da 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 da, until it called edge viscosity compute limiter. And then you see how it lists this file name here? If I double click that, it copies this text up here. Then you just click up here and you hit enter, and it'll jump there. Okay? So the way to switch between files, which I never explained, is you type in the name of the file, main.cpp, and then you put in a line number, and it jumps there. If you just type main.cpp, it won't jump there. So you can just, if you just want to go to the file, you can hit line 1 or 20. Okay? So that's how you jump around. And then so this is really fast because I had an error. If you get like a seg fault or something, you can just fire it up in the debugger. You can run it, it'll die, you just type where, and then you just come up here, and shucks. So this interface is not modern. And you double click this and you hit enter, and you can see that on line 327, it died. Now this is an example of exactly what Matt said, where I actually changed the code, the source code, and I didn't realize that if you change the source code, this is showing the fixed source code, but I didn't have this thing here, if dx squared is greater than 13, 10 to the minus 13. So you can see here what's happening is if I just mouse over dx squared, it's 0. So I'm dividing by 0. That's what's happening. Yeah?
And if you scroll way back up in the GDB window, it had a warning that the source code was newer than the executable.
Yeah. So
you should look for that.
So that you should look for. I run the debugger from CMake, which automatically recompiles, so I don't usually have this problem, but that's true. Anyway, so you can just mouse over and you can see right here I'm dividing by 0. One thing I want to say is normally your program may or may not quit if you divide by 0 or take square roots of negative numbers and stuff. There's a document on the wiki page that I wrote that explains how to turn that on in G-Fortran, GCC, and G++. It's not intuitive. You have to just type some random stuff in, and it works. So, and it's super useful because you want to know when that kind of thing happens. So one thing you can do is I didn't really show you the power of this thing. So if you type, there's a special command you can type here, or you can just right-click and click New Display, and you can type in the name of something. So there's a global variable in my code called gcooper. So if I display that, it's a pointer, and this is the value of the pointer. So it points to a Cooper object. If I double-click this, it loads that Cooper object here. So now you can see this is the Cooper object. These are all the variables in the Cooper object and what their values currently are. So again, I can double-click any of these lines, and it'll kind of make these different boxes and like link them together and stuff. So I can scroll here. You see it makes these different boxes, and you can drag them around. And if you have a bigger monitor, it's actually a lot more useful. But so here there's a variable called m checkpoint freak cycle that's set to 20. So this is where like the power of these different display things is really useful. If you've got really complicated data structures that you need to look at, you can do this. You can also print. You can also, I think I have a variable here called Quord. Yeah, Quord is just an array of